We have these four functions: cos absolute value of x plus absolute value of x, and similarly sine and plus minus. Right? We have these four functions. We have to see which of these are differentiable at x equal to 0. Right? Now, when a function is differentiable, what does that mean? It has to be continuous and it has to be smooth. Right? It should not have any breaks. It should not have any spikes like this or corners like this, whatever. It has to be actually smooth. Right. Now, looking at these functions, cos of absolute value of x, cos x is equal to cos minus x. Right. So, absolute value of x, it doesn't change anything. So, cos x plus x when x greater than 0, this is equal to, and cos x minus x when x less than 0, because cos of plus x equal to cos of minus x. Right. Now, if we look at this function, absolute value of x, how does it look? It looks something like this. And cos of absolute value of x is nothing but cos x. It looks something like this. We are concerned about the point at 0. Now, this cos x is actually a smooth function, and absolute value of x has a sharp point here, right? Obviously, when you do the sum, it will look something like this. It will look something like this, right? And there will be a sharp point at this point, right? So now, because for this sharp one, you have to negate. You have to get something like this, right? Then this and this cancel, this and this cancel. The sharp edge can cancel. But here, cos is actually a smooth one, and if we add this sharp one to the smooth one, obviously there will be this kind of point we will get here, right? So obviously this is not differentiable at x equal to 0. I will show you the exact graph also. It looks like this, right? See, the sharp point has come here, cos x plus absolute value of x, because absolute value of x has a sharp one here, and the same sharp one is maintained here also, right? Similar logic we can tell for cos x minus absolute value of x. See, cos x, the maximum value of is 1, and absolute value of x is always positive, 1 minus some positive thing. So this will always be lesser than 1. And at the same time, by the same logic, because we are doing the negative, we will get some sharp point here. Right. So that is this point. So you can see it clearly. That is this one. Right. Obviously, the graph is not smooth at this point. When x equal to 0, the graph is not smooth. Right, because of this absolute value of x thing. Right. Now, coming to sine of absolute value of x plus absolute value of x. When x greater than 0, this becomes sine x plus x. When x less than 0, this becomes sine of minus x, which is minus sine x plus absolute value of x, which is again minus x when x is less than 0. Right. So, now what does that mean? When x is very close to 0, we are talking about x very close to 0. Right. When x is very close to 0, sin x will be close to x. We already know this. Sin x and x will become very similar. We are talking about x in radians. So sin x plus x will become like something like 2x. Here minus sin x minus x will become minus 2x. It becomes something like. So when x is greater than 0, the graph will look something like this when x is very close to 0. When x is less than 0, this side it will look something like this. One side the slope is 2, another side the slope is minus 2. Right. So obviously slopes are not matching from both the sides. So it is not differentiable at x equal to 0. Right. At x equal to 0, both sides the slope should match. Then only we will say it is differentiable. When we say it is smooth, that means the slope should match whichever side you measure. Right, so it looks up like this, something like this. See this green one. One side the slope is 2x, slope is 2. Right, this side, another side slope is minus 2. So it is not matching. Similar logic we will give it here. This becomes sin x minus x when x greater than 0, and minus sin x plus x. Right, sin of minus x is minus x, minus of minus x is plus x. When x less than 0, again when x is very close to 0, this becomes x minus x, which is equal to 0. This becomes minus x plus x, which is also 0. So both sides the slope is matching here. right? Minus x plus x. Both sides the slope is matching here when you approach from the left side of 0, right side of 0. So that's why this one is actually smooth. This one is actually differentiable at x equal to 0. So it looks something like this. Please note sin x is lesser than x always, but it will approach x, right? It will try to approach x, right? Now, so for example, x will be something like this and sin x will be something like this. So sin x is always lesser than x when x is positive, right? Now, this is how we have figured out that D is the correct answer. But this is a very informal way of looking at things. We should know the formal way also, right? Let us try to do the formal approach. Formal approach, what is the derivative at a point? We know derivative is limit h tends to 0 of a function f of x, then f of x naught plus h minus f of x naught by h. What is this? This is roughly saying there's a function, there's a curve like this, then this point is x naught, and this point is x naught plus h, and this point, this y will be f of x naught, and this y will be f of x naught plus h. Basically y2 minus 1 y1, which is f of x naught plus h is y2, minus f of x naught is y1 by x2 minus x1. x2 is x naught plus h, x1 is x naught, so x naught will get cancelled by h. Basically, this is equal to saying y2 minus y1 by x2 minus x1 when this x2 and x1 are very close. H tends to 0 means these 2 points are coming very close. So instead of a secant, we'll make it a tangent. Right, the slope of a curve at any point is equal to the slope of the tangent. Right. So now in this case, this limit h tends to 0 should exist. What does that mean? Limit h tends to 0 plus should be equal to limit h tends to 0 minus. Left hand limit and right hand limit should be same. Now let us evaluate the right hand limit. X tends to 0 plus. Then which one should take? We should take cos x plus x. Right, f of x naught plus h. What is x naught? X naught is 0. We are evaluating limit at 0. Right, f of 0 plus h minus f of 0 by h. This limit we have to evaluate. What is f of 0 plus h? This is nothing but cos of 0 plus h plus 0 plus h. Right, we are substituting 0 plus h in this one. Right, which is nothing but cos h plus h. Right, f of x naught plus h is equal to cos h plus h minus what is f of 0? F of 0 is cos 0 plus 0. That means cos 0 is 1 minus 1 by h. Right, this limit is nothing but cos h minus 1 by h plus h by h, which is nothing but 1. Right, limit h tends to 0 plus. We know the standard limit cos h minus 1 by h, cos theta minus 1 by theta when theta tends to 0. Right, this is nothing but we can write it as 2 sin square theta by 2 by theta, and then we can multiply with another theta. Likewise, we already done this. We already proved this limit is actually equal to 0. Right, so we have this 1. So when you are approaching from the right hand side, the limit is actually equal to 1. Right, h plus or 0 plus limit is equal to 1. Right, that is what you have seen in the curve also. 0 plus we are approaching, the slope is actually equal to 1. Now what happens to 0 minus? 0 minus, then f of 0 plus h. Then we have to take this function, right? When x is less than 0, f of 0 plus h is cos of 0 plus h minus 0 plus h, which is nothing but cos h minus h. Right, and what is f of 0? Cos 0 minus 0, which is nothing but 1 by h. Limit h tends to 0 minus. See, it is the same thing. Here we have plus 1, here we'll get minus 1. Cos h minus 1 by h minus of h by h, which is nothing but 1. Right, we are just taking this one this side. Right, now this limit h tends to 0 plus cos h minus 1, this we already discussed by h is equal to 0. 0 minus 1 is equal to minus 1. So when you are approaching from negative side, 0 minus 1, the slope is actually minus 1, which is what we are seeing here also. Right, this slope is actually equal to minus 1. Right, the tangent at this point is equal to minus 1. So one side slope we are getting +1, another side slope we are getting -1. So that's why the limit doesn't exist. Limit has to exist mean both sides the slope should be same. Similarly, exactly same, instead of plus, here we are getting minus. So here, if we do the same thing, same plus and minus difference. So here we'll just get the opposite, right? When you're approaching from the right hand side, we are getting negative slope. When you're approaching from the left hand side, we are getting +1 slope. Here -1 slope, here +1 slope, right, guys? So similarly, we can do for remaining ones also. Similarly, we can do for the remaining ones also. So ultimately, the answer is this one is the correct answer, right? We have seen the informal way also, we had seen the formal way also, right, guys? Hope you like this. Thank you.